Quite a nasty question, but as always, let's draw on what we have. So we're told AB is equal to BC, and both of those are equal to X. Then we're told that BP is equal to BQ, and those are 10. So I'm just going to sketch that on as well. We're trying to find this angle here in the middle, or the cosine of that angle, should I say. And we're given that this angle is 30. Now to find what the cosine of this angle here is, it's on a triangle. If I draw a line between P and Q, it's not a right angle triangle, so we can either use the cosine rule or the sine rule. In fact, it's possible to make this into a right angle triangle. I could extend that down and then consider half of it. So it could be possible to do it that way. But I'm going to put the cosine rule route here because I have two sides, the angle in between and a side opposite. So the cosine rule is that a squared is equal to b squared plus c squared minus 2 lots of bc cosine a. So 2 sides squared minus 2 times both of the sides times together, cosine of the angle in between them. And I'm going to rearrange this to make cosine A the subject, because we're trying to find cosine of this angle. So from cosine's perspective, I'm going to follow a backwards BIDMAS approach. So when we're performing operations, we have to follow this order of operations, but when we're rearranging, we're essentially undoing these operations. So we can do this in reverse. We don't have any subtraction because this minus is times by the cosine A from its perspective. We have addition though. From here, we're adding a c squared and a b squared. So we want to take those off. So we're going to get minus 2bc cosine A. That's equal to a squared minus b squared minus c squared. We're doing the opposite in order to shift those to the other side. So we don't have our addition. And now we're multiplying. We're multiplying by 2bc. So to get rid of that, I want to divide by minus 2bc. That's doing the opposite. That's going to cancel it out. And now I can substitute in the values which we have on here. So angle A is actually PBQ. So cosine of PBQ is equal to a squared minus b squared. So a squared is the side opposite. That's PQ minus b squared and c squared. Those can be either. So those are both 10 squared. Divided by minus 2 times by 10 times by 10. Now you can see that we need to try and find PQ. And there must be some reason why they've given us this x and the angle of 30. And it forms another triangle. So if I draw a line from A to C, length AC is the same as PQ because these are congruent parallelograms. These two lines are parallel, CD and AF, meaning that the distance between them isn't changing. So PQ, AC, they must be the same. So if I wanted to, I could switch this PQ for AC. But now to work out AC. AC is the opposite side, so that's going to be side A in this equation. And to get A the subject, I can just square root all of the other side, and both sides. Now I'm going to do a bit of forward thinking here, but this square root and this squared, they're going to cancel out. Because when I'm calculating side A, I'm going to put it back into this for AC. And all of the square root of this is going to be squared. So I could ignore that square root if I want to. But just to be exhaustive at the moment, I'm going to write it out anyway. So B and C, those are both x. So we have x squared plus x squared minus 2 times x, which gives you another x squared, times cosine of 30. All of that is square rooted. And before I plug it into the cosine PBQ equation, I'm going to simplify this down a bit. So we get 2x squared minus 2x squared lots of cosine 30. Drawing a quick sketch of your cosine curve, it does something like that. 30, that's about that value there. Starting at 1, we've gone down a little bit. This value is root 3 over 2. This is one of the values you just need to know. So we're going to get minus 2x squared times by root 3 over 2, all square rooted. Now I can put that back into my original equation. And I'm going to simplify as I go. So AC squared, as I said, this is just going to cancel out with the square root. So I'm going to get 2x squared minus 2x squared lots of root 3 over 2 minus 2 lots of 10 squared. 10 squared is 100. I'm minusing 200 in total. And that's all over minus 2 times 10 is minus 20. Times about 10, I get minus 200. Now at this stage, I'm going to see how I want to simplify this. And I want it so that it's in this form here. So we're getting quite close. We've got the x squared, we've got the root 3, we've got the 200. But I can break this fraction. I can consider this as two separate fractions if I want to. So all of this over minus 200. Minus 200 over minus 200. Just to see if this works, if I have 3 plus 2 over 10, that's going to give me 5 over 10. But if I did 3 over 10 plus 2 over 10, that does also give me 5 over 10. So that seems to work. Of course, that's not categorical proof that it does work, but it's good enough for the purposes at the moment. If it works with simple numbers, it's probably going to work. It's a good rule of thumb. Now, minus 200 over minus 200 is equal to 1. And if I'm dividing by a negative, that brings the negative to the top. So it's going to be minus something. And then it cancels out the negative down below, so I can ignore that now. And it's going to be something over 200. I'm going to bring out the x squareds as a factor. So I'm going to times all this by x squared. That's going to times the numerator by x squared, not the denominator, so that's okay. So if I bring out the x squared as a factor from this one here, that's left with 2. And I have minus 2 lots of root 3 over 2. Now there should be a times in between there. Otherwise it's a mixed fraction. And 2 times by something, divided by something, that's going to cancel out. I'm going to get down to my minus root 3. Now just to make it exactly the same as the other, I'm just going to put that in brackets.